I explained this, I derived it like that, and then we're good to go. Away we go with various examples. Then I give you the different types of monopoly, and then I go through the different types of monopoly diagrammatically. And I'm not sure that I do any more equations here. Okay, so we're going to do this little bit. We'll start here. I'll just go to this. Now notice everybody here. Let me get rid of this for a moment. We'll come back to it later. In this case, we have the same thinking that we had before. Profit is maximized so long as the revenue from an additional unit is greater than the cost from an additional unit. Everybody notice this? So for example, here, the revenue from an additional unit, right here, is greater than the cost. And here, the revenue, the margin from an additional unit, is greater than the cost. Until we get to this point here, when they're the same. But if we went beyond that point, if the monopolist went beyond that point, an additional unit, there'd be less revenue than there was cost from an additional unit, so profit would start to fall. So that's the intuition of it all. But let's run with something like this. I'll just move this right out of the way for the moment. And we'll do something like this. I'll give you another example and we'll move quickly with it. Let's do this. Let's say P is 520 minus 0.1 cubed, and P equals say 100 plus 0.2 cubed, like that, everybody? And I still have these on exams. Now let me just, competitive equilibrium reminds you. Equilibrium would work out to imply that these two would be equal, and Q would equal, in this case, 420 divided by 0.3, which would be equal to 1,400, right? Good, thank you. And P would equal, remember, this is the demand function, and since this is I can give you it as marginal cost function of the monopolist, and later sometimes I'll do that. You'll see why subsequently, but the marginal cost function of the monopolist is the supply function of the competitive firm, because the competitive firms, competitive industry. So this is the competitive industry. The price here is 520 minus 0.1 times 1,400, which in this case is 480. Right. 380, thank you very much. Which is equal to always 100 plus 0.2 times 1,400, which is again 380. Okay, so that's beautiful. So we're set up. Now, let's find the total variable cost here. Now, what is the total variable cost? What it is the sum of the marginal costs. Right? It's the sum of the marginal cost. So it's the area under marginal cost. That would be equal to sum of marginal cost, which would be the area under marginal cost, which would imply it's a trapezoid in this case. So it's going to be between, what's the mean equilibrium? We got 100 plus, this is the trapezoid, right? Plus, 380 times 1,400 divided by 2. So that's going to be like 700 minus 280. Remember that is what? 336,000. Now I did that as the trapezoid underneath the marginal, took the area underneath marginal cost, but it's also equal to average variable cost times Q. Now, what is average variable cost, by the way? Could you guys tell me? Would you know what average variable cost is? Well, you do. Because the original variable cost is 100, and the variable cost, if you will, the marginal cost of the last one is 380. So the average variable cost is the average of 380 and 100, which turns out to be, what is that? Let's see, 240. Yeah, 240. Yes, 240, yes, exactly. Would be 240 times 1400, which presumably is also 336.00. Everybody? Do you understand? So the variable cost, the average variable cost, is the average of all the variable costs. The marginal cost is the sum of the variable cost of an additional unit. So if you took the average of the marginal cost, you would have an average variable cost. Agreed? So it's a simple way of doing it. So our average variable cost is that. I'm going to draw this on the next page. Sorry, just so you see this. So we'll draw this like this. In our case here, we have like this. Okay, so we have whatever this is. I'm going to do, what is this, 120? I'll shoot it up like this. This is supply, where this interest, was it 100 or 120 there? 100, okay? This is 100. Like if I'm drawing this, right? So that's 100 as an intercept for supply. Now for your thinking, you want to ask yourself the demand function. Its intercept is up here at 540, everybody. Now has it got the same slope? Steeper, flatter, what is it? Flatter. So you've got twice the slope. So this would be demand. And so we know that the demand would be above, the intersection is going to be above the midpoint. So this is 540. Right? And so then we work in here, this in here. My second, one of the midterms has an example like this. So if you think about it in class, it would be a lot easier if you did it in the exam. So this is our equilibrium. Notice our equilibrium is 380. It's closer to 540 than it is 100. And that you kind of understand that. And this is 1400. Now the total marginal cost is the sum of all the marginal costs. So don't draw this in. I'll just draw it in. This is the total variable cost, right everybody? It's the sum of all the marginal costs. Or I could just cut it right in the middle, kind of like this, and take the area of this rectangle, because I can figure out average variable cost the way that I did that at this output. So if I actually drew, average variable cost would be the midpoint like that, there. But if I was drawing average variable cost, I would draw it like this, right? At this output, average variable cost would be 240, so it would look like this. Can I do this? I don't know. Would this be correct? Would this be the way average variable cost would look? Look at it closely. Could average variable cost look like this? No. No, it couldn't. This has to be 240, but the minimum marginal cost must cut to the minimum. So we must draw something, say, like this. This would be average variable. This would be average variable cost. Just think about it, right? Because it's got to go through the minimum there. And then here, right here, at 1400, it is, say, 240. I'm just working that out, okay? Just showing you what we actually can figure out from this. Okay, get rid of it. We don't need it. More than that, I'm interested in the operating profit of the firm. That's the difference, the producer surplus. The difference between the price and the marginal cost of each unit. That gives you the total excess revenue over variable costs. So we're interested in this area here. And this, of course, is just a simple triangle. So operating profit is this. Let's step back. I'm more interested in operating profit, which I can find two ways. One way I'm going to find it by that triangle, which is, what was my equilibrium? What was my price? 380 minus 100 times 1400 divided by 2 gives me what? Sorry? 100? Yeah, so it's a 196,000. Do we have a way of testing that? Yes, we do. This would be equal to total revenue minus total variable cost, which in this case would be, and when you go home, I want you to go through this and just see that playing around with what we already know. And we can do all this kind of stuff, right? Total variable cost, so that would be, total revenue in this case is 380 times 1400 minus 336. 336,000. So is that what it is? What is that? 380 times 1400 is what? Minus 336,000. Same thing, everybody? So make sure you understand what I'm doing here. So that is the total variable cost of the firm. Now, if it's a competitive, what is fixed cost if the firm, I'll call it the industry, because this is the industry, is at long run equilibrium? If the competitive, what is the fixed cost? If, remember we're talking about competition for the moment. If the competitive industry is at long run equilibrium, what is fixed cost? You all know the answer. What is it? All right, let's think it out. Yes. At long run equilibrium, what do we have for a competitive firm? Zero economic profit. That means you have zero difference between total revenue and total cost. And total cost includes fixed costs. Now we know total revenue, and we know total variable cost, and we know total operating profit. So what is fixed cost? It's equal to the operating profit. It's 196,000. Now, so that's zero economic profit. Our operating profit is exactly what we need to get the average rate of return on our capital, i.e. fixed costs, right? So this implies fixed cost equals $196,000. Now I need you to think about this. It's not difficult, but it makes you, this is what the course is in a sense all about. This is what the questions, the multiple choice questions, are problematic, because they sometimes ask these questions which you want to be able to figure out, but you may not be able to do it. Okay, so there it is. So let's draw this diagram then. As we have it, I'm going to get rid of this. And I need to draw the average cost function. Where would it be? At long run equilibrium, where would the average cost function be? Long run equilibrium for the competitive firm. Where would it be? Yes, Carl.
I want to say it's at the equilibrium. Like
yes,
the
so we have to
the
have
average cost is at the equilibrium.
Something like this. I'll draw it like this. I'll shift this up a little bit. So this, I hate that. Okay, this is the average cost function of the industry Remember, this would be the sum of all the average cost functions in various firms. It's at a minimum, or a little bit back there, right? This would be the average cost function, competition, and this would be supply for competition. I don't have to say for, now there is no such thing as a supply curve for monopoly, because the supply function would be the marginal cost function. It's the, given a price, what the monopoly would produce. But the monopoly is not a price taker, number one. And number two, it doesn't determine the output solely from the cost function. It also takes into account the demand function, right? So the monopolist doesn't have a supply function. But this supply equals the marginal cost function of the monopolist. All right, so competitive equilibrium is zero economic profit. Now let's do monopoly. On the diagram, how do we figure out monopoly equilibrium? Yeah. Yeah, draw marginal revenue twice the slope. On the diagram, you don't have to do what you do, but just try to make it twice the slope, right? Like that. Then this would be, so this is marginal revenue of the monopolist. But only the monopolist, not of the competitive industry. Or actually, it's true of the competitive industry, but not of the competitive firm. And then we have here, for the monopolist, this intersection of that and marginal cost defines the output of the monopolist, defines the price charged by the monopolist, defines the average cost of the monopolist, you'll see right here, defines the economic profit of the monopolist, right here. Now we usually don't look at monopoly compared to long-run competitive equilibrium. We normally look at it like a short run. But this shows you that the monopolist in this case doesn't make these huge kind of profits where we get most of our diagrams because we're talking about short run. But the monopolist definitely gets an economic profit. Everybody? Now let's stop for a moment and think about this, because this is very puzzling. Let's say, where did I draw my marginal revenue function to? Right here. Let's look at this point right here. I'll draw it like this. Now, we're going to come back to this after, a break. We'll go back to monopoly and everything. I just want to put the seeds into your mind here. Would a monopolist ever operate on the right-hand, to the left, the right-hand side, the right-hand half of a demand function? Would a monopolist ever operate at equilibrium in the inelastic portion of a demand function? The answer is no, never. So, for this reason, you'll notice that, of course, profit for any firm equals total revenue minus total cost. Now let's look at this a little bit. What happens to total cost as the monopolist produces less? Always. Fixed cost is fixed. What happens to variable cost as the monopolist produces less? What do you think? It decreases. It has to decrease. As you produce less, your total variable cost, your labor, fuel costs fall. So it turns out, in this direction, there are no exceptions. I'll put here. So, P increasing, Q falling. I'll do it, actually change it. P rising, Q falling always implies, there could never be an exception, a fall in variable cost, total variable cost, or variable cost, okay? That could never happen, change. Now what about P rising, Q falling? What happens to total revenue? If price goes up and quantity falls, what happens to total revenue? You know the answer? You do know the answer. Think about elasticity. If it's inelastic, what happens to total revenue? P goes up, quantity falls, what happens to total revenue if it's inelastic? Total revenue goes up, right, everybody? In the inelastic portion of any curve, price dominates. So in this case, price goes up. So in this case, total revenue rises if inelastic. So it turns out right here, number one, what we're talking about right here, no monopolist produces an inelastic portion of demand because profit rises since total cost falls, fixed cost is fixed, and total revenue rises. Everybody? So the monopolist never produces in the inelastic region. Ever, ever, ever. Okay, now what about the elastic region? This turns out to be interesting. If I said to you, is the total revenue of a monopolist greater than a competitive firm, the competitive industry? Usually not. Because the monopolist never produces in the inelastic region. They produce in the elastic region. So notice here, elastic demand implies fall in total cost. So as they produce less, cost has fallen, but something else, a problem, but fall in total revenue. So the thing is, the monopolist operates somewhere in the elastic portion so long as their reduction in output decreases their costs more than it decreases revenue. And that's how we find that point by marginal revenue, marginal cost. So the weird thing is, and I'll burn you probably on this in the final, if you're not careful, total revenue for the monopolist is very often less than total revenue for the competitive firm. But that's not what counts. The profit is greater. The monopolist reduces total cost always by cutting output and tries to increase total revenue, relatively speaking, by reducing output until they get the optimum amount. We'll talk about this later, but you start thinking about this, it gives you more insight. Okay, that's the basic background. Now I'm going to say, we could easily figure out what this profit was for the monopolist. We would have no trouble. So let's figure out, while we're at it, what is monopoly equation? Let's do it quickly. Equals implies we're going to have 520 minus 0.2 Q equal to 100 plus 0.2 Q, which implies Q equals 420 divided by 0.4, which is 1,050, exactly. Which implies P equals 520 minus 0.1, that's kind of handy, times 1,050. And that is 415, if I'm not mistaken. Right, everybody? So notice, this monopolist reduced output pushed up the price. Let's just check out their total revenue. Total revenue equals 415 times 1,050, which is equal to what? What'd you get as a number? 415 times 150, what is that? 435,750, which I believe is probably greater than competitive equilibrium, which is whatever it is, calculated from 380 times 14,000. What is that? Where's 380 times 14,000? Oh, so it's actually less. So let's see, it's less than. So competitive equilibrium in this case is is in the elastic portion. So this is, what did you say it was? 32. So it can happen, but oftentimes it's less. Greater than less. Well, it is. In this case, no, sorry. Notice monopoly equilibrium, which I would say, is in fact less than competitive total revenue. Total revenue for the monopolist is less than competitive total revenue. Well, let's see what the profit is for the monopolist. Economic profit for the monopolist is, let's figure out the variable cost, which would be 415 minus 100, which would be what is the I think it's 257.50 is the average of 415, between 415 and 100, is it not? 415 minus 100 divided by 2 is 257.50, I think. Is it? Yes or no? Yes, good. Times, so the variable cost would be times 1,050 plus the fixed cost, which is 196,000. And we have to subtract from this. Let's figure out what the total cost is first. So what is this number in total? You just add that up. When you go home, you don't have to worry about this before the exam, but you go through this and see certain mysteries. What's this number? 7,000. 74,000? So you're giving me the profit? Or the total sum of these two? Just give me the total cost. People, what's the total cost? Try to follow along. There's a point to all this. It demystifies it. What's the total cost? 460? 466,000 is the total cost. Sorry? 375. Okay. That's the total cost. But notice, everybody, we're going to end up with, wait, this can't be right. It's not 257, it's what? 415, what's the average of 415 and 100? That's 315, 157, 150, 257.
265.
Sorry?
265.